Hello and welcome to 12.3 Notes titled Surface Area of Circular Solids. We're going to be looking at finding the surface area of a cylinder, a cone, a sphere, and a rather challenging shape known as a frustum. So the first one we're going to look at is one that you dealt with before, and that's a cylinder. To find the surface area of a cylinder, you need to find the lateral area and the two bases, very similar to a prism. The lateral area, though, since it's circular, is under the formula circumference times height, which might be known as 2 pi r h if you remember some of the formulas you memorized back in Algebra 1 for this. In your own words, we're going to look at why the lateral area is the circumference times the height. And using one of our great websites here, mathopenref.com, it really shows it really nicely. So if we have ourselves a cylinder here, and if you kind of unravel the cylinder, you may notice that the actual lateral area, which is the wraparound part, unfolds into a rectangle. And notice that the height of the rectangle was the same as the height of the original cylinder. And if you look at the base of the rectangle, it's actually the wraparound, which is actually the circumference of the circle. So notice that the surface area will be 2 pi r times h, which is what you just saw. And then we're also going to have to find the area of each circle using pi r squared, and the circle will be congruent, both of them. So why is the lateral area the circumference times the height? Well, you got to kind of put in your own words here. I kind of said it slightly different just here. The cylinder has a rectangle that's wrapped around it. The rectangle's base is the circumference of the circle, while the height is the normal height of the actual cylinder. So instead of base times height for the rectangle, it's actually circumference times height. So that's why you see the 2 pi r h, which some formulas put it as pi times diameter times h. Either one would work. So your job next is to find the surface area of the cylinder. I showed a cylinder really quick. You could pause the video, try it on your own, and then restart the video in a moment. We're going to show our answer right now though. So we got 2 pi r h plus our two circles, 2 pi r squared. And at this point it's just plugging into the correct spot and following our algebra that we've been practicing for a while. As we work our way through, we then combine our like terms. We're going to try and leave an exact answer because it doesn't say. So 312 pi inches squared. So that would be surface area of a cylinder. Our next one's going to be surface area of a cone. So very similarly, it's kind of like a pyramid here. We're going to find the sum of the lateral area and one base, just like a pyramid. I don't know why I wrote 2 there. How about that? So I definitely need to switch that out. So obviously we have one base there. However, we have to look for the lateral area. It's a little bit different though than the cylinder. It's the circumference times the slant height, because in a cone the slant height would be on the edge there. However, it's 1/2 because if you unfold it, there's a few ways you can look at it. It could unfold kind of into a little bit of a triangle setup. So to find the surface area of the cone, first I got to show you the cone. I drew a classic one right here, 5 across. I give you this side right here. At this point you could pause the video and kind of follow the formula. Remember, this will give you the lateral area, but then you also need to add the bottom base. Okay, so we're going to work our way through it. So lateral area will be 1/2 times pi times 10, because that's the diameter, times 13 plus pi r squared being 5 for our radius. We're just going to work our way through, and we're going to end with 90 pi square meters. So that would be cone. Our third shape, which is a rather hard derivation for the formula, is the sphere. So we're actually not going to kind of go through where the formula comes from, but it is 4 pi r squared. Once you have the formula, it's very easy to use. figure out where it comes from. There's an example using a lot of similar triangles, and there's an example using some calculus. So something we may come back to in a few years. But now that we know the simple formula, to find the surface area of the sphere, very simply follow this here. So we're just doing 4 pi r squared. Sure enough, we're just going to get 100 pi. There are no units on the figure, unit squared. And now we've been telling you in the beginning, we're going to do a complicated shape coming up last. The complicated shape is called a frustum. So we're going to find the area, surface area of the figure if the radius 1 is 6, so the top radius is 6. The radius 2 here is 18. So that one's 6, that one's 18. And the height is 16. So you may notice, hopefully you notice here what's going on with this shape. The frustum kind of looks maybe like a seat in a way, or a lampshade, depending, one of those fancy seats, a lampshade. But basically, if you complete the shape and continue it up here, you will actually have a cone. So it's actually like taking a cone and kind of taking off the top half of the cone to form the lampshade type of shape. So we need, basically, we're going to find the surface area of the cone, at least the lateral area, and then we're going to find the lateral area of the top cone that would have been here, and we're just going to subtract it from the whole cone. And that's really it. We're going to make sure that we add the base back in as well. Actually, the 2 bases, because we have 2 different ones. So we got to figure out what that top cone looked like. So if we look at it carefully, the next figure may help a little bit. I know you definitely may need to pause the video here if this goes a little too quick. But notice here, so we have our 6, we have our 16 for our height, which we can draw here. We know that this part's 6, which means this part over here is 12, figure not drawn to scale, since it formed 18 total. This gives us some information that we need here, because now over here we have a 12, 16, and this part, the S labeled here, has to be 20, because it's a 3, 4, 5 right triangle. And then we kind of got to figure out here what this top part will be. The 10 appears in, and the question is where that actually comes from, and we're going to show you now. And it comes from the idea that you actually have this massive triangle, which is 18 across here, and we have this small triangle. And in fact, the small triangle and the big one are actually similar. Okay, so they are similar because of classic angle-angle. They definitely have an angle in common, and we can kind of assume smartly that this line and that line is going to be parallel, so we're going to have corresponding angles. That's enough to set up a proportion from chapter 8. So we actually know we could put 6 to 18 will equal x, which we don't know this one originally, that's why it's in purple, over x plus 20 would be the whole triangle. Solving that will give us 10. So that tells us this one here. And now we kind of have enough information to figure out the total surface area here. So to figure out the total surface area, we're going to take the lateral area, okay, and the area of our bases, though we're actually going to have 2 of them in the original shape. So I kind of put a fancy formula there, but we're going to work our way where each of this comes from. So if we look at the entire cone, the completed cone, it would be pi times radius times slant height, because remember this entire slant height would be 30 because we have to do the 10 and the 20. And we're going to subtract out the top cone, which will be pi times radius times its slant height, which is 10. And then over here is the addition of the 2 bases. So we got pi r squared giving us 36 pi, and pi r squared giving us 324 pi. Using some algebra skills here and some multiplication skills, over here, once we complete these and subtract, we get 480 pi. Once we add these 2, we get 360 pi. It totals 840 pi inches squared. So that is certainly a tough one. It usually doesn't come easy the first time. we'll definitely work on a few more in class, and you'll see different examples, and doing it a couple times generally yields good results afterwards. All right, have a good one.